In the box below, complete one of the valid Lewis electron-dot diagrams for the SO3 molecule. Be sure to include all valence electrons, including lone pairs. Visual. S is the central atom, surrounded by 3 O atoms. A valid diagram must show a total of 24 valence electrons. S can be shown with an expanded octet, e.g., 3 double bonds, or 2 double bonds and 1 single bond, or 1 double bond and 2 single bonds representing resonance forms. All atoms must have appropriate lone pairs to show a total of 24 valence electrons. Scoring. 1 point is earned for any valid Lewis electron-dot diagram. Predict the shape of the SO3 molecule based on the diagram you completed above. Trigonal planar. Scoring. 1 point is earned for the shape that is consistent with the completed Lewis diagram in Part A. Under some conditions, SO3 decomposes to produce SO2 and O2, as represented by the equation below. 2SO3 is in equilibrium with 2SO2 plus O2 increment H standard equals 180 kilojoules per mole of reaction. Under what temperature conditions will the reaction be thermodynamically favored? High temperatures, low temperatures, all temperatures, or no temperatures? Justify your answer in terms of the change in enthalpy and the change in entropy during the reaction. The reaction will be thermodynamically favored only at high temperatures. The reaction will be thermodynamically favored when increment G standard is negative. Increment G standard equals increment H standard minus T increment S standard. Increment H standard for this reaction is positive, so at low temperatures, when the value of T increment S standard is small, increment G standard is positive and the reaction is not thermodynamically favored. Because increment S standard for this reaction is positive, 2 moles of gas decompose to produce 3 moles of gas, increasing entropy. High-temperature conditions give a large positive value for T increment S standard. This will result in a negative increment G standard, and the reaction will be thermodynamically favored. Scoring. 1 point is earned for correctly linking increment H standard to unfavorability at low temperatures. 1 point is earned for assigning the correct sign to increment S standard and linking it to favorability at high temperatures. A chemist fills a rigid vessel with SO3 at a certain temperature until the pressure of SO3 in the container is 0.83 atmospheres. The SO3 decomposes as the partial pressures of SO3, SO2, and O2 in the container are monitored over time, as shown in the following graph. A change is made to the system at time t1. Visual. Answer the following based on the graph. 1. Draw an X on the time axis to show when the system first reached equilibrium. Describe the change that was made to the system at time t1. After the change was made at time t1, the partial pressure of SO3 increased while the partial pressure of O2 decreased. Explain this observation. The student should draw an X on the time axis approximately halfway between 0 and T1, where the partial pressure curves first become flat/horizontal, indicating that concentrations/pressures are constant and equilibrium has been established. Scoring. 1 point is earned for an acceptably positioned X. Additional SO2 was injected/added to the reaction vessel. Scoring. 1 point is earned for the correct answer. The addition of SO2 at time T1 increases the concentration/partial pressure of a product, making QP greater than KP. To restore equilibrium, the net reaction shifts in the reverse direction to the left, consuming products SO2 and O2, and producing more reactant, SO3. Scoring. 1 point is earned for a correct explanation indicating that the system shifts left to establish a new equilibrium, consuming O2 and producing more SO3. Use the information above to answer the following. 1. Write the expression for the equilibrium constant, Kp, for the reaction. Determine the value of Kp for the reaction. Kp equals PSO2 to the power 2 asterisk PO2 slash PSO3 to the power 2. Scoring. 1 point is earned for the correct Kp expression. Kp equals 0.33 to the power 2 asterisk 0.17 / 0.50 to the power 2 is equal to 0.074. Or Kp equals 0.41 to the power 2 asterisk 0.14 / 0.57 to the power 2 is equal to 0.072. Scoring. 1 point is earned for substituting appropriate values from the graph before or after T1. 1 point is earned for correctly calculating the value of Kp. Values between 0.072 and 0.074 are acceptable.